trying to figure out what the rules were, stuff, and this is the rules. They tell us up here what the rules are. To play Powerball, you pick 5 numbers. So you got 5 numbers. Pick out of a pool of 1 to 69. And then you have the Powerball out here that's from 1 to 26. Alright, the Powerball can be, so like let's say the first number is 5. The Powerball can also be 5. There's no rule on that it can't repeat. Okay? So, first thing, let's just forget the Powerball's out here. 1 through 5 are 5 numbers there. Permutations or combinations?
Permutations. Because you can repeat numbers on the Powerball? Like, can you go 13, 13, 13?
No.
No?
So you can't have repeating numbers, but what if I did this? What if the numbers we picked
It's also different order, so it's
were that?
combinations.
Is that the same as? Yes. Sure. Who is that? Miss Williamson? All right. I'll send him down here in a minute. So, are those the same or different?
Different.
They're the same.
I thought order mattered in
No,
Powerball.
it doesn't in Powerball. At least that's what it says here. You must select 5 numbers from the pool.
Because I thought like they got the ball out when 13, 7.
Right, but it doesn't have to be in that order. You just have to, if you get the number 13 anywhere on your card, that's the number 13 is. So otherwise, instead of being $1 billion, it'd probably be up to like a whole bunch because nobody ever picked the right order. All right, so is it permutations or combinations?
Combinations.
What goes out front? What goes second? Somebody help us out.
1, 1, 2, 3, 8, 5, 1, 3.
So now 1, 1, 2.
3, 8, 5, 1, 3.
So about 11 million. Not bad. I mean, that's, I think it's $2 a ticket now instead of, it might even be more than that, I don't know. But back in the Stone Age when they were doing it, it was just $1 a ticket. So it'd be, if I just paid $11 million, bought every single number. I think it's $2 now, so I'd have to spend about $22, $23 million to get every number. But I'm gonna win $1 billion. What's the problem with that logic?
Get the Powerball.
That's true. The Powerball is gonna make it even worse. But if it was just this, it's $1 billion. What's happening right now? Every one of your grandpas is where?
At the ball.
There, huh?
Getting the Powerball.
Getting the Powerball. I was waiting for somebody to say in the grave, but that's where my grandpa's at. I was waiting for you guys to say that.
That's right.
Pretty dark and ridiculous.
That's right.
All right.
Yeah.
So I'm glad you didn't say it, Wade. That was nice. I was waiting for some smart aleck to say it. All right, so everybody's buying it. So you spend your $22 million. Does that mean you're going to make your money back? Depends how many people win it. Hopefully,
Just you.
hopefully if it's just you, then you're all right. But if there's 7 winners,
Yes, but it sounds
you gotta split it 7 ways, and then now you're probably in the hole. All right. So we have that. That's just for the 5 numbers. How are we gonna add in the Powerball part to it? How many choices for this Powerball out here? 26 choices. We don't really have to do, I mean, we could do a combination and say 26 taken one at a time. It's just 26, isn't it? What do we do with this number and that 26? Multiply. So So take that number and multiply it by 26 and what do you come up with?
292201338.
That? Is that right?
Yeah.
So now instead of 11 million, we're up to what?
200, almost 300.
Almost 300 million. So now, if we're gonna buy every ticket,
Spending.
and it's $2 a ticket, and if it, let's just round it off to 300 million, now we're spending about $600 million.
Get $1 billion back.
Do we get $1 billion back?
If you win it.
The tax is what?
You get it in checks, you know? You get it, not just one.
I can't remember.
Over and over.
I'll let you get your phones out right now. Grab your phone out and look this up for me. Cash payout for the Powerball tonight. Just look up, if you look up cash payout for Powerball,
You get 30 annual payments, you get $30 million.
What's happening tonight?
Cash payout is 300, oh, for, you can go into your state. We can, find Ohio real quick. $293 million, that's what you get back right now. You get $1 million, but if you get the 30 payment plan, you get $591 million.
so we go out tonight, or this afternoon, and we spend our $600 million just so we can win.
We lose 400.
We're gonna lose $300 million. I think the payout's actually gonna end up being a little more than that, but I think
It's
about-
293,493,775.
Say it again.
293,493,775.
I see, I think it's gonna be closer to like 400 and some million, is what I thought I heard the payout was gonna be if it was over $1 billion.
That's what it said, like, it said 80 million and then 497 million.
Is that saying for today though, or is that just normal?
For Monday, October 31st.
Maybe I'm wrong, maybe that is all it is. I thought it was more than that, but.
Add federal tax, you get 313 million.
So federal tax is gonna be, what, $20 million? 30
More than that.
million, 20 million.
It says, additional federal taxes, 64 million. And then 24% federal tax, 119. I don't think I want to pay no more.
So, if we went out and we bought one ticket, what's the probability that we're gonna win?
One, and that,
One out of that number.
what percentage?
Tell me how many zeros I need.
9.
9? 8? Is it just 8?
You know, listen to Alexa with me.
Alright, 8, and then what's the number? Here's after that, and then so far back here. So watch, I'm gonna change it to a percent. That's the percent of the time that you're gonna win.
It's good odds.
Now,
I like the odds.
so now Wade back here, cause he's got a bunch of money, says, yeah, but I'm gonna not just buy one ticket, I'm gonna buy
two.
two.
Multiply that.
You multiply that by 2,
Wow. 3-8, crazy. Or 6-8.
woohoo!
Hitting it big.
By 3.
And then you're really on it.
If they're only like $2, I like 20.
So, go after school today, go to the
Gas station.
go to the gas station and stand there, and all these people that are buying them go, make a sign out of this.
I don't think you're allowed.
Make a sign out of this one and say,
You got it.
this is your chance of winning. Yes!
But every time you stop gambling, the next time you were gonna gamble, that's when you were gonna win big.
Yeah, you keep believing that. Oh, Phoenix, I hate having you in class, but you make it fun sometimes when you say silly stuff like that.
Can we do 23D? Yeah.
On the homework. Get back to my slideshow here. Which one did you say?
23D.
23D.
Or we just do all
You
23.
want me to do all of it? 23 says there are 6 women and 5 men interviewing for 4 cashier positions at Walmart. Part A. In how many ways can the 4 positions be filled? So we don't care, men, women, whatever. How many people are they choosing from? Oops, I'm sorry. Is it permutations or combinations?
Combinations.
Combinations, because
Okay.
Gage gets hired, he didn't care if he gets hired first or last, it makes no difference, right? So how many people are we choosing from? 11. How many are we taking?
4.
Somebody do that for us.
30.
30?
30.
300.
Not 30.
30, 30.
I said 330.
You said 30. I did not.
And how many ways can the positions be filled if all women are hired? Now, Gage, you're out of luck. You were born the wrong sex. They don't want goofballs males working at Walmart. All right. So how many women are we choosing from?
6.
How many are we taking?
4.
What's that give us? 15. C. And how many ways can the positions be? And how many ways can the positions be filled if 2 women and 2 men are hired? This is where it gets a little tougher. We sort of went over these, and I should have went over them a little more. All we're doing here is we're taking 2 different things and we're going to multiply. So we want 2 women. If we want to hire 2 women, how many women are we choosing from? 6. And how many of those women are we picking? And we want to hire 2 men, right? So how many?
5 and 2.
5 out in front and 2. Somebody do this first one for us. What's that? 6, 2, 15? I thought 6, 4 was 15. 6, 4 and 6, 2, 15? Huh. Sort of strange, isn't it? What's 2 plus 4?
Draw questions from there.
Everybody sort of see that? See the number out front is 6. If you got 4 and 2, then it would be the same. How about the men? 10? And we just multiply those 2. So how many different ways? 150.
We put that.
Yeah.
D. And how many ways can the positions be filled if at least 1 man is hired? At least 1 man.
That means there could be 2, 3, 4 men, but at least 1.
So at least 1 man means that there could be 2, could be 3, could be 4. But it means that there can't be what? No men. So if we found, if there was no men,
There's 15.
It's just 30 minutes.
we could do that, couldn't we? We know this is the total, all the possible ways that anybody could be hired. But if we do that minus no man hired, how could we find no men being hired?
D. It was all women.
So 315 minus, or 330 minus 15? Is that the way we do it? What's that give you? 22. In a train yard, there are 4 tank cars, 12 box cars, and 7 flat cars. How many ways can a train be made up consisting of 2 tank cars, 5 box cars, and 3 flat cars? Do we care what order these are in? Alright, so as long as we got 2 tank cars, that's all we care about. So let's do the tank cars first. If the order doesn't matter, then we're doing C. How many tank cars do we have to choose from? And we want 2, right? Is that what it said? And then we're gonna take that answer and times it by how many flat cars? It's 12 to choose from, is that what you said? Oh, box cars, all right, let's do box cars then. 12 box cars, how many of those are we choosing? 5. And then flat cars, and we're choosing how many? But do all that first.
450,000.
We got a different answer. 320?
Yeah.
Oh, I put the wrong number. That'd help.
Yeah, put the wrong number in there, probably not gonna work.
I put 4 tank. I put 6 tank cars.
I got 830. I don't know.
That's what I did, but you just added up the 3 instead of multiplying.
Instead of multiplying.
Oh, weren't that far. I just did the same thing. I had the right idea. Poor executed. Maddie wasn't helping. Honestly.
Other questions?
The top 5%.
29.
No, but I'm gonna see.
29.
I'm in the top 40%.
There are 10 seniors, 8 juniors, 5 sophomores, 3 freshmen on student council. A committee of 6 members is formed. Determine the number of ways to form the committee given the following conditions. The committee is chosen at random. Committee's chosen at random, that's telling us that we don't care about what? What order, what class, whatever. So, permutations or combinations? Combinations. How many are we choosing from? 26. How many are we taking? What's that give us?
Never mind. 230, 230.
Everybody agree with that? 230,230. Next one, the committee must have 3 seniors, 2 juniors, and 1 sophomore. So for the seniors, it's gotta have 3 of them, we're gonna choose 3 of them. 10. For the juniors, it's gonna have 2 juniors out of 5. 8. And sophomores, now let's be careful here, how many are we picking? 6, so is that the number we want? Now, they could have left one off and said, okay, the last one could be any, but they didn't. So you're just finding all those, what's that here?
16,800.
Anybody else get that?
150.
150?
53.
Or 53? Bet you added them up again.
Then we might.
Yeah, you gotta multiply. Committee must have 4 seniors and 2 juniors. So 4 seniors, how am I gonna write that? 10 and 4, 2 juniors, is that what it said? So that's 8 and 2 again, isn't it? What's that give us?
5,880.
Last one. The committee must have at least 4 seniors.
Huh.
How are we gonna do that?
Subtract the seniors on the top one. So it'd be 16. It'd be 10 NCR 4 times 16. 2. Okay.
Is that gonna work? At least 4, so that means it could be 4, could be 5, could be,
So we got
6,
line
right?
3
Yeah,
and
yeah, yeah.
then subtract.
so we have this number up here, right? This is all the different possible ways that it could be. We want, so if we're gonna subtract something, it's probably gonna be using this number minus something, right? So we wanna subtract off if there's
3, 2, and 1.
3 seniors, 2 seniors, and 1 senior. How can we do that? Because if we just do 10 C3, is that really giving us our different possible ways?
So we gotta find.
Because we don't know the sophomores, juniors, and freshmen, right? So that'd make a whole lot of different ways. So how could we do it? I think Gage sorta had the right idea. What'd you say to do, Gage?
You take 10 C4.
So that means we're doing 4 seniors, all right?
And you subtract 10 from 26. And then it'd be 16 C2.
Anybody? Do we wanna subtract 10 from there? Cause we're saying it's at least 4 seniors, right?
You don't subtract.
Do we need to subtract any? No, because
Because you can still do this.
we want, how many seniors? At least 4, so this is taking care of the 4 part, right? Over here, we really don't care what happens over here. It could still be seniors, it could be juniors, could be a junior and a sophomore, could be anybody, so we're still taking what? 26, so we still want all of those there. Somebody do that for us. What else get that? 68,250. Does everybody see where that came from? Make sure. I know some of these, I gotta stop and think a lot of times. Alright, let's see, what are we doing here? That one, we wanted 4 seniors, so we wanna take care of that. We know the different combinations that we have 4 seniors. Then, the other 2 positions, we don't care who they're filled by. It could be a senior, it could be a junior. So we want all of those, and then we multiply them together, because we could have our 4 seniors, and then 2 people somewhere else, or we could have 2 other seniors, and we just have to find all those different combinations. Other questions? 15? 15. How many vertical arrangements are there of 8 flags if 4 are white, 3 are blue, and 1 is red? So on 15, we got 8 flags, right? So I guess what they're saying, if you go down to like the red stadium, they always have the pennants flying up in order of whatever the division, 2, 3, 4, whatever the division is at that point. And sadly, it's looked this way here for the last few years, where the Reds are always the last flag down there.
100 losses.
Shut up.
Farm team.
Probably a Cubs fan, then.
Phillies.
Yeah, Phillies, since they're good this year.
Just Matt Castellanos is better. On the Phillies.
So, if we line them up that way, all the different arrangements. Now, the way they have it, they got 4 white flags. I don't know on the problem because it didn't explain it.
Doesn't say that in order.
If we put white flag number 1 up top and then white flag number 2 second, is that gonna be different than white flag number 2 being on top and white flag number 1 being second?
Yep.
I don't know. I
This
don't-
was under like the section.
It's permutations.
So it's.
So it's permutations, but if we make this one white,
Well, white flag 2 is off white, and white flag 1's cream blue, so.
see, that's what you get for listening to you. Is that different than if we switch them around? I don't know, I'm gonna let you guys choose. So, do you think that's the same if we switched them around, or do you think it's different? It's different? Alright, if it's different, then we're just doing permutations. How many flags do we have?
8.
And how many are we taking at a time?
4, 3, and 1. 8.
8. We're taking all 8 of them, right?
8 factorial.
What's that come out to be?
40,300.
That's if we're saying flag number 1 is white, flag number 2 is white, but putting them in a different order matters. If Riley thinks that that's not the case, so switching these 2 around isn't different, then we gotta use that other formula for distinguishable permutations. Okay, so if we were doing that, how many flags do we have? 8 factorial. And then we'd have to divide by, how many white ones are there? So 4 factorial times 3 factorial, and then 1 factorial, which we don't care about. Riley's looking at it funny because it's a big difference, isn't it? So if we're saying white, 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 white is different than white, 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 there's 40,000 different ways we could line them up there. If we're saying no, if the 4 white are all on top, that's the same no matter what order they're in. There's only 280 different ways that they could be lined up. Get a lot more done if you weren't doing all the extra drawings. Other questions? How do you what?
So I did that, but I
because,
With bottom of print.
well, what I would do is,
You do the top and divide by the bottom.
yeah, that's still not gonna work, because your calculator's still gonna do the same thing. You're gonna have to use parentheses somewhere, yeah, you're gonna have to tell your calculator, hey, we're doing this, then we're dividing that answer by this whole thing. Because otherwise,
I think parentheses around a factorial divided by parentheses 4
So-
factorial times parentheses 3 factorial.
So you
Yeah, I got 10,
I still got
10.08.
so you did that, and you still got
Yeah.
10 something?
Yeah.
Why would that be? Let's see, what's the calculator thinking here?
And I tried it without any sort of parentheses, so I got the same answer.
Yeah.
I'm trying to think why the calculator, if you put parentheses around both those, that should come out the same.
A factorial.
Parentheses, there's a syntax error.
Divided by.
Huh?
Oh, I didn't.
When they put that in the calculator, they got what?
They said they got this right here, the way it is right now, they said they got 10,000.
Yeah, even if
So
it's
I
eight.
put in parentheses 8 factorial divided by parentheses 4 factorial times 3 factorial.
Oh, I got 1080 that way.
So,
So you have to go parentheses 8 divided by all of that bottom parentheses, not parentheses 8 factorial times parentheses 3 factorial.
so what Maddie said was, if you get rid of that.
No, I got the parentheses added that exact way.
Yeah, you put it in that exact way, you get 280.
280.
Yeah.
I got
But
280.
if you put it in like 8 and then 4, like 4 factorial in parentheses and 3 factorial in parentheses.
All separate, yeah, then it's gonna do something different. So you're saying if you put it in this way, it does give you the.
Yeah, if you do it, I just put it in that exact way and I did it. So you have to do it that
Alright, so
exact
that,
way.
see, that's what was confusing me, cause I'm thinking that
Okay.
this should be right if it's on the calculator that way. And I was trying to think, alright, why would the calculator give me a different answer there? I wouldn't.
I'm just confused.
I wouldn't put the top in parentheses, alright? Do the top, then hit divided by, and then put that in parentheses, cause you want to divide by that entire thing, not just one or the other. Other questions? 13.
Athens and basketball?
How many distinguishable permutations are possible using the letters of the following words? So we want distinguishable permutations, alright? So for Athens, how many letters? So 6 factorial. How many A's are there?
1.
How many T's?
1.
H's?
There's no repeating them.
No repeating, so all we really need to do is what? 6 factorial, what's that? For basketball,
B repeats twice and B repeats.
how many letters? 10? 10, right?
Mhm.
B repeats twice, so that's 2 factorial.
A repeats twice.
A repeats twice, that's another 2 factorial. L repeats twice, so another 2 factorial. Anything else? So all that. Now, see, if I'm doing this, because I don't wanna have that trouble that you guys are having with the parentheses and everything, I know 2 factorial is 2. 2 times 2 times 2 is what? 8. So I do the top and then just say divided by 8. If at all possible, I try to do some of my head so that I don't have to worry about the parentheses and everything else. 453,600. See, how many letters here? 10. How many S's? What else is there? 2 U's.
And 3 T's.
again, I'd probably do this 2, that's 2, that's 2, so 2 times 2 is 4. 3 times 2 times 1 is 6, 4 times 6 is 24. What could we do? We already got this answer right here. I don't have a calculator, so we divide it over here by 8. What are we gonna do here to get our answer? We're gonna divide it by 24, but we already divided by 8 to get this answer. Divided by 3, because 3 times 8 is 24. So if I don't have a calculator and I'm looking at this, I know 3 will go into 4 once. That leaves 1. 3 will go into 15 5 times. 3 will go into 3 once. 3 will go into 6 twice. Is that what it came out to be? Did you catch all that, Gage? Is your mind
I'm gonna make sure I have a calculator.
as big as mine that you can do stuff like that in your head?
Oh, yeah.
You guys just gotta understand math. It's not hard. I'm not doing anything special. I'm sure not the, I don't even like saying stuff like that. Icicle. What's on top? 6 factorial on bottom. 2 factorial times 2 factorial. That's 4.
So it'd be 725.
720 divided by 4, how much is that? What is it? 180? Oh, I was looking at the wrong problem. I think it was 280. That's okay. Different problem. Make sure your names are on those. I have you turn them in here in a few minutes. Yeah, I forgot to plug them when I found it. The other paper also, the other one, which,
Adrian, we're gonna
we pass those in the groups.
what's the score each committee? What's the score of the travel? It's probably gonna be like.
I don't know if I want to do this or not.
This could be bad. Dan's at home, so.
We're gonna do something
Everybody
different, but I don't know that
gets to
we'll
watch
have
this
time.
movie.
We'll spend a lot of time on that. Plus, I'm gonna spend a lot of time taking Ben's phone away from me. Put it away. Let's do this first, then we'll decide. What's gonna be on this test? Come come Wednesday.
Sid, were you on your?
Yes.
I was not. I'm sitting right there, look, that's a compliment I won't go on. Yeah, no, he texted me.
On this test, I'll write down some stuff you'll have to write quickly. We'll go run through this sort of quickly. Probability. Simple probability. Favorable outcomes over total outcomes. Anytime you're doing probability, it's favorable over total. Factorial. Hopefully you know what factorial means by now. So if you have something like 5 factorial, that means 5 times 4 times 3 times 2 times 1. In factorial, when we're doing on the problems and stuff, you know that. The other thing that you might need to know about factorial is 0 factorial is what? 1. Now most of you, I guess, don't need to know it because you're using your calculators all the time, but you might want to be careful. Because we've seen what happens when you're using your calculator if you punch it in wrong and
Yeah, the only thing I wrote down was the calculator steps.
it's not good. Hopefully nothing goes wrong with your calculator.
Yeah.
Sample spaces, I don't know, let's make up something here. Sample spaces, all the all the female students in the classroom, what would our sample space be? How would we show the sample space? What do you gotta do? Oh, guarantee there's gonna be 10 of these on there now.
However many of us there are.
So you just write down 10, you write down every option. So what would we write?
Everybody's name.
Right, you write out everybody's name. Right, if we just want the female students, then you just write down all the female names. And during the test, if I put that question on there, Phoenix, I don't want you asking Alexa, hey, how do you spell your name? Because then I'm gonna think you're cheating. All right, so just, if you spell it, get close. Nobody has to know if you spelled it wrong or right, except for me. You understand
Yeah, I
that?
know everybody's name.
There's a lot of people that spell my name wrong.
Alexa. How do you spell it?
Yeah.
So that's a sample space. Be able to list all the possible outcomes. That's a sample space. Tree diagram, remember a tree diagram looks like this. I have this, and then you got branches coming off of each thing. Be able to make tree diagrams for whatever it is that we're doing. Then you might have branches that come off of that, each one of those. I should put a real long drawn out one on there, shouldn't I?
I won't do it.
You won't do it?
No, I'll skip over that.
Make it worth 50% of the test. Cause me and Phoenix got a bet, don't we? I could. Alright, so, sorry, been about your luck, but Phoenix says he's gonna skip it. That way I'm assured to win my bet. Fundamental counting principle. Fundamental counting principle. You can use fundamental counting principle on a lot of different permutation stuff. Right? Fundamental counting principle, and I do this on a lot of different problems. Instead of using permutations or trying to decide what it is, I'll just say, okay, if I have this lock and that lock's got 4 numbers on it for its combination, I put 4 blanks, and I say, how many choices do I have for the first number? How many choices do I have for the second number? How many choices for the third, fourth, so on and so on. And you put those in there, and all you do is multiply. Ordered pizza last night because my wife was out of town, so ordered pizza. Place offered 10 toppings, so I picked the topping. We got 4 toppings on our pizza. How many choices did I have for the second topping? 9. How many for the 8 or for the third topping?
8.
For the 4th topping? And then what do you do with all those? That's the fundamental counting principle. That, again, does that tell you a probability? No, that doesn't tell you a probability, it just tells you how many total possible outcomes there are. So what's the probability that you get the pizza that I ordered? 1 out of whatever that number comes out to be. Types of probability, what were the 3 types of probabilities? Guarantee there's several of these on there. Classical. Classical is just when you're using what? It's just straight math. What's the probability of rolling a 2 on a die? 1 out of 6. That's classical probability. Alright?
Empirical.
Empirical. So classical is, I don't really know how to, it'll be easier to explain the other 2. Empirical. Empirical, I think it's what I wrote. Huh? This is the E? I don't think it is.
EMPERICI.
Is it? That's what we should be worried about right now is the spelling.
Like,
Em-
notes on test.
Empirical. Does anybody remember what's empirical deal with?
3.2 over 12.
So when are we going to use that? That's when you're given what? Usually when you're given like a chart or something where they've done this and said, we surveyed 1,000 people and 430 said this, 210 said this. So when you're using some kind of survey or something along those lines. Empirical. What's the third one?
Subjective.
Subjective. What's subjective? Give me a occupation that uses subjective probabilities. I gotta go see one today.
Doctor. Oh, I guess doctor's put in. No, you gotta check that.
You were just like that?
Take a look at it. Subjective, doctors use subjective probabilities. Because they do what? They diagnose stuff and they look at it and they say, okay, when we've seen this, 30% of the time, it's been this. 20% of the time, it's been this. 60% of the time, it's been this. So hopefully they go with the one that was 60% of the time, right? So subjective. Other things that use subjective probabilities, insurance companies. Insurance companies, when they look at how much they're going to charge you for your car insurance, they are being subjective because they're saying, well, 30% of the time, the Jackie Arthurs of the world crash their car, so we're going to charge her more. Am I right?
Kate.
Caden's the one that's bad.
No, Nathan Flack.
Oh my God.
Caden, I think, didn't Caden have a sister that went through here? Did she have an older sister or something? Does anybody know?
Mackenzie. I think it's like her cousin.
I thought she had an older sister.
Like, a lot, she has an
Yeah.
older cousin.
Yeah, she's older.
Oh, is it?
Yeah.
I don't know, but she said
It's
I
like,
hit my door against her car, which isn't true.
yeah.
She also just
Nice.
completely grow out.
Yeah, like, and then she blames on me.
I know.
And then she made her friends think it was me too.
Seems like I had a relative of hers a few years ago
The
in
Dillos?
in this very class.
Hello?
And, huh?
The Dillos?
We won't go any further. And that poster's gonna hit you in the head. And that person crashed their car just down the road here and went through like the fence or something, one of the farmer's fences down the road.
Good deal.
And I know exactly why, but of course, the person's mom was about my age. I went to school with her. She flat out lied to her mom, said a deer ran out in front of her. And
That's what happened to me, Jordan, and Bergen.
That's what made him go off the road.
Yeah.
That's true though.
Deer ran out in front of me,
Deer.
me, Jordan, and Bergen.
Even
we
the
were,
people on that
we were
porch
taking a
saw
turn. We were taking a turn, just,
And the bad thing is that this person went home the same direction that I go home each day, and there was times I'd follow them, and guess what I'd see every single day?
On my phone.
you weren't doing that while driving?
If you still leave your phone back,
You gotta cruise like
this.
this.
Not ever on shoes on?
Yeah.
You gotta full lean back, gotta adjust the hands sometimes.
Ben, you don't do
Sometimes you
that.
gotta
do you?
rotate it
The
on
only
your
time I ever
stomach
look
while you're
at the phone
driving.
while driving is to change
Or
the
sometimes you're flipping.
All probabilities gotta be between 0 and 1. This is gonna be a big, big thing next chapter, but this chapter is still sort of big. All probabilities, 0 to 1. I shouldn't say it's gotta be between 0 and 1, because could it be 0?
It could be.
What's going on if the probability is 0?
Not
There's not a chance that that's gonna happen, alright? What's the probability if it's 1?
always gonna happen.
It's always gonna happen. Alright, so chance, Phoenix gets a 90 on this test.
One.
Yeah, you don't wanna buy me donuts.
Because you're gonna get in a hunger. That's why.
I'm supporting you.
I think you got it.
Law of large numbers. Law of large numbers just said if you do something over and over and over and over and over and over again, you're going to end up getting closer and closer and closer to the classical probability. So if I flip the coin, if I sit here and I flip the coin 10 times, does that mean I'm going to get 5 heads and 5 tails? No. If I flipped it 100 times,
You get close.
am I going to get 50 heads and 50 tails? No, but I'm probably going to keep getting closer and closer and closer to it being 50% one, 50% the other.
So why does a coin flip always land on tails?
Why does
It's
it
always tails. Because tails never
He's
fails.
just bad flipping.
Tails never fails.
Maybe tails is a little bit heavier than heads.
Complement of an event. Remember, complements written like this. If you got probability some event A, the complement is that little tick mark on it. What's the complement mean?
Opposite.
It's sort of like the opposite. So if I said, if event A here was probability of drawing a female's name out of our classroom, then the complement of that would be the probability of doing what? Drawing a male's name. All right, so it's sort of the opposite. I don't like to say opposite because that's sort of makes it seem like it's got a negative with it. But conditional probabilities, independent and dependent events. Remember, independent and dependent events. Something like drawn from a deck of cards. If I draw a card from a deck of cards, what do I have to do to make the second draw independent of the first draw? What do I gotta do with the first card that I drew out? Put it back in. That would make them independent. If I kept it out, then the second event depends on the first one. Multiplication rule, you just find the probability event A times probability event B, we were just doing some of that, times probability event C, so on, so on, so on. It's using the multiplication rule. So you got to remember, when we're doing that, and this is where I hate saying this, but that's usually when you're doing separate things. You're doing this event, then this one, then something else. Doesn't always work that way, but mutually exclusive. Two events are mutually exclusive. What's that mean?
They don't enter, like, they don't. They don't.
They can't happen at the same time. So if I'm dealing with a deck of cards, or no, let's use a die because everybody knows what a die looks like. 6-sided. Give me 2 events that are mutually exclusive.
Rolling a 6 and 2 at the same time.
Rolling a 6, rolling a 2. Those 2 can't happen at the same time.
One roll.
All right, in one roll. They cannot happen at the same time. Now, rolling a 6 or a even number can happen at the same time, so those are not mutually exclusive. Remember, with not mutually exclusive stuff, it's probability of A plus probability of B minus the probability that they happened at the same, that they were the same, or whatever, that they did happen at the same time. So you sometimes gotta do that. What's this? How do I read this? Probability B given that A has already happened.
Like, without cards.
Right. Addition rule, this uses the addition rule, so probability of A, what we just wrote up here, plus the probability of B is the addition rule. And again, usually, hate saying this, but usually that's when we're doing or. So we want to roll a 2 or a 3 on the die. And if we want to roll a 2 or a 3, how many times are we actually rolling the die? 1. That's a little different than we want to draw a king and a queen. If we put and in there, then we're drawing how many times? Twice. Permutations. Hopefully, if all that we just went over, you remember pretty much what permutations are. I know Brendan over here doesn't need to, but some of you might want to write down that formula down there just to make sure you remember it. It's gonna suck. Oh, crap, my batteries went dead. Middle of test, and Ebersole's charging $20 for 4 batteries. Making retirement money. Phoenix is gonna check this thing.
What are these bad batteries they give us? Max L.
Who gave it to you? Me?
No, the box. The chemical.
Some company that probably gives them to them for,
TI-84PL sim.
that's what the little battery is inside of it. That's the watch battery that's in it. What do you have to remember with permutations?
They can
Order
go
matters.
2, 1, 3, 1, 2, 3.
Alright, so maybe just remember race. Alright, it's like a race where where you finish at makes a difference. Should a permutation number be bigger or smaller than a combination number?
Bigger, way bigger.
Bigger. Permutations are a lot bigger, combinations a lot smaller. Distinguishable permutations. This formula again, now there is nothing on your, that one you might want to write down because there is nothing on your calculator to do that. Distinguishable again means if we do that set of numbers 1, 2, 3, 4, 1, that's the same as 1, 1, 2, 3, 4. Same thing. So we want distinguishable ones, not where we just switch the ones around and we can't tell if we switched them or not. Most of these are done with the words, all the letters. We just got done doing Athens, basketball, icicle, I think was one of them. I don't remember what the other one was.
Oh, did we ever get a number for statistics?
Substitution, do what?
Did we ever get a number for
Yes,
statistics?
386. I did figure that out. You want me to explain it? Did I explain it completely or
You
did I?
said you had to.
You said you wrote it out yourself.
I wrote it out, but did I explain how else you could find it?
Oh, the really complicated way we have to do like 400 things for our answer.
Combinations. Combinations, the arrangement of objects where order makes no difference. I hate saying it that way because it's easy to get the two confused. Just know that for combinations, if I pick Wade, Phoenix, and Gage, that's the same as picking Gage, Phoenix, and Wade. So if it's that order, the order they got picked in doesn't make any difference, then that's a combination. What happens when you do something like this?
What?
There's only one way that it can happen. Alright, now does that work with permutations? Nah. Something bigger number, right? Just the probabilities, this is nothing, just, you know that if you're trying to find the probability, permutations or combination is just your total possible outcomes. And like we just got done doing the lottery thing over there where the favorable outcome was 1 and then the total was whatever that big number was on the bottom. With this is the way, when we were doing that statistics, it might make a little more sense to you now since we just got done doing some of those permutations, combination stuff. We have, I didn't want that. Did I spell it wrong? I'm gonna remember all this. Everybody's laughing right now. When I grade your test, I'm remembering this. Taking all points for spelling on this test. There's,
How are you gonna know if we spell it wrong? You spell it wrong yourself.
Do you know this?
I can barely tell how it's spelled.
spelling.
Fail. Fail.
You spelled my name.
He gets a failing grade because he didn't do the homework.
I'm taking off a bunch of points on your
Yeah,
test.
should we spell Phoenix right?
Yeah, he spelled my name right.
Huh?
Because he spelled my name right.
I know, I spelled it right.
Spell statistics, right? So
I'm gonna make
Oh,
you,
yeah, it's not
you gotta spell every young lady's name. Remember I said that problem earlier? That's the one I'm gonna put on there. You better spell every single one of them right. You better not ask any of them because it's a test.
I'm gonna get a master schedule from the office.
Not having this.
So, the way this is, what you have to do when you're doing this is you have to, there are 4 different things that could occur. Because we have 4 different kinds of letters in here. We have a letter that appears once. We have a letter that appears twice. There's 3 different kinds of letters. And we have letters that appear 3 times. So, what we have to do is we have to separate those out. And on this first one, we gotta take this. This is, we have no letters the same. Alright, so our first possible way that the thing could be is we have no letters the same. This one is gonna be, if we have 2 letters the same, this one 3 letters the same, and then what was the 4th one? Oh no, we had 2 letters the same, and then we had 2 letters the same, but the other 2 different. So 2 letters the same, other 2 letters the same, 2 letters the same, the other 2 letters different, and then 3 letters the same. So there's 4 different ways that we could put these letters together, and we can use 5C4, and we can do that. And then what you're gonna end up doing is you gotta multiply that by, there was 5 letters in our word. If I'm just counting S, T, A, C, just the letters, not counting the ones that repeat. So there's 5 different letters. Well, if we're taking them just one, the ones that don't repeat, then what we can have here is times 4 factorial. So this is where it's hard to explain. This is how many different words we can have starting with that one certain letter. And then there's 4 of those different letters. So this 4 factorial, that's where that comes into play. So we get that, and it ends up, this first one's like 120. So there's 120 different words, and not actually words, but 120 different 4 spot letters or 4 spot words, whatever, that we could get out of this using S first, then using T first, then using A first, then using C first, then using I first, so on and so on. And for the second one, this one is 2 letters the same and 2 different. And to do that, we do C. If we're getting 2 letters the same, we got 3 choices. There was 3 choices of letters that were the same. S's were the same, T's were the same, I's were the same, if I could spell. And we're taking one, just, it's 3C1 because there's only one way that those can go together. And then we times that by, what did I times it by? 4C2, because there's 4 different ways that we could match them up, taking those 2 letters, so on and so on. Is that making any sense? Probably not. Not really. What it is, this is like our letters and the different ways that we can put the letters together. This is like how many different words or how many different 4-letter combinations we have. And we have to do that for each of these situations. If no letter's the same, 2 letters the same, 2 different, 2 letters the same, the other 2 the same, 3 letters the same, and 1's whatever. So we have to do each one of those situations separately. Then once we get all of these, how many there is in each one, we're going to add them together. Not, like I said, probably not the best thing to try to explain to you. I need to get rid of that question so I don't ever have to try to explain it again. Your assignment is this packet, which I thought I laid out here, but apparently I didn't. What do I do with it now? Yep. What you can do, this is your assignment, this packet, come up here and grab one. While you're up here grabbing it, you can lay the other 2 packets right there in the pile next to it.
There was the one, and there was the one.
There was one packet and then a worksheet.
The one in class wasn't a packet.
Just lay it, sorry. Lay all of it right there in one pile, I'll figure it out.
Silly.
Sorry.
Hey, Ben. Ben, you ready to start lifting next week?
I know.
You ready to start lifting next week?
Sophie and I are best friends now.
If she wants to again, she can put her in. I prefer it.
You got any plans?
Yeah.
Alright.
That ain't my decision.
That's what everybody says.
I might honestly just do stats with Ben.
Matt is bored.
He deserved that. He really did.
So it's just like,
You're lucky she didn't do it.
do me a favor, turn off the recording.
Don't do that.
I think we had
We
maybe
just
we had
tested.
to make a sex or anything.